Let's go through the test. All right. So here we have the sine graph, and it's going 4 up. It's stretched. Normally, sine goes up to 1 and down to -1, but it's multiplied by 4, so it's going up 4 and down 4 from the center line. So the amplitude is 4. B, the period. The period is this number in here. It's 2 pi divided by the period is 3. We take the period divided by 2 pi divided by the period, that gives us this number. So if I multiply by p on both sides and divide by 3 on both sides, I get the period to be 2 pi over 3. So 2 pi divided by that number is the period. 2 pi divided by the period is that number. Equation of the midline. This whole graph is moved up +2, so it's y equal 2. And the horizontal phase shift, well, it's x minus 0.5. As long as this is in parentheses like this, then that's the horizontal phase shift. So it's moved right 0.5. It's moved a half a unit that way. So that's number 1, 2 points each. Number 2, it looks like at 0, this is going up. That's a sine curve. Now you can do it with cosine, but that's normally if you're on the center line going up at 0, easiest to do is sine. And this is the midpoint because it goes the same amount above as below of that. So it's +2 at the end here, but it's going 2 over that and 2 under that, so the amplitude is also 2. So it's y equals 2 sine. Now it's 2 pi divided by the period. So how long does it take to repeat? Let's see, from here to there is, that's going up to going up. That's 2 pi over 3. So the normal period divided by the actual period is the number we put in front of the x. And since this is going at 0 is on the center line, we don't have any horizontal shift. We just got to figure this number out. That's what's got to go there. So we have 2 pi divided by 2 pi over 3. So when you divide by a fraction, you invert and multiply. So you got 2 pi times 3 over 2 pi. And we get 3. So it's 3x. Same as this one, actually. This was a period, 2 pi over 3 period, and we had a 3. This has a period of 2 pi over 3, so we have a 3. Now let's look at this one. So this looks like either a tangent or cotangent. So let's just kind of review. Tangent normally starts off at 0 if you think about the unit circle. At 0 degrees, it's 0, and as you follow the tangent line, going up with the angle, goes from 0 to infinity, and then over here it goes to negative infinity back to 0. So it goes from 0 to infinity by pi over 2, and then it comes back by pi. And if you work backwards, this goes down here to pi over 2. That's the tangent. This one's going the wrong way. Now I can flip that over, or I can use cotangent. Cotangent is on this line, so it's 0 at pi over 2, and for these first ones, it's positive infinity going to 0. And then it goes over here, goes to negative infinity. Well, that looks like the cotangent, but this kind of looks like cotangent, but it'd have to be shifted over. So let's do the tangent one first because it's right on it. So I'm going to say y equals tangent. And then we've got a center line. Where is the center line? Well, here's -2, here's 0, so it's at -1. This is the tangent flipped over because it's going down instead of going up. So it's the tangent flipped over. And so how do you tell the amplitude? Well, here's the center line at -1. And normally, if on a tangent, if you go halfway, we're at 1. Halfway between 0 and pi over 2. Halfway between this on this side, we normally are at 1, down or up. It's actually normally 1, but it's going down because it's flipped. Well, here's 1. This is only down, not half of it, but only a quarter of it. So this is negative 2.5 or negative 0.25 or negative 1/4 tangent. And now we still got to figure out the period here, plus a -1. Now, what's the period? Let's see. It goes from positive infinity to negative infinity from pi over 2 minus pi over 2 to plus pi over 2, which is a whole pi. The period is pi. The normal period for a tangent is a whole pi. So pi divided by pi is 1x. And that's it. Now, if you had chosen to do cotangent, then the amplitude would still be -1 or be 1/4. We wouldn't want to do negative because the cotangent goes in the right direction. And it would still be 1x because the period of the cotangent is also pi. Goes from 0 to pi. So it's still 1x, but it has to be shifted sideways. The cotangent crosses 0 at pi over 2, and we have to move it back over to here, so we have to go minus pi over 2, no, plus pi over 2 to move it minus. And then the center line would still be a -1, the midline. So either one of those would work for that one. Okay. The cosine is 0.2. So if I were to look at a unit circle and said the x-coordinate, cosine is the x-coordinate, was 0.2, I could be either here or there and have 0.2 on the x-axis. So this would be the x. That's where it's plus 0.2. And so if I go a negative x, the cosine is still 0.2. It doesn't change the sign of the value. And if I called this x, then this would be negative x, and it's still 0.2 both ways. So the cosine stays 0.2. Now, the sine, what would the sine be? Well, the sine could either be this one or that one. The radius is 1. This leg is 0.2, so I'd go the hypotenuse. squared minus the leg squared. Square root is the other leg. So 1 minus 0.2 squared, so that's 1 minus 0.04, and that would be 0.96 plus or minus would be here, either, square root. Either square root of plus square root of 0.96 or minus the square root of 0.96 would be this side. So the tangent is the y over the x, or the sine over the cosine. So it could either be plus or minus square root of 0.96, the sine, over the cosine, which is 0.2. Okay, now we're doing exact principal values, so we have to pick things out of the correct quadrant. Cosine is always positive here, so we don't do there. We go from here to here to get positive values and negative. It says negative 1/2, which is here, which is an angle of pi over 3, or 120 degrees. But we're getting ready for calculus, so we do radians. B, sine. Sine is positive here and negative here, so we use these two quadrants, and we have to get negative 1. Well, the sine is negative 1 right there. The y-coordinate is negative 1. And so we can't call it 3 pi over 2, because that's not between negative pi over 2 and pi over 2. It's got to be negative pi over 2. Cosecant, which is the reciprocal of the sine, uses the same two quadrants as the sine, and we got to do 2. So this is reciprocal of sine, so the sine inverse of 1/2 is what we're looking up. And so in these two quadrants, the y value is 1/2 here, which is an angle of pi over 6. Oh, I said this one wrong. This is 2 pi over 3 to get over to here. 1 pi over 3 is here. 2 pi over 3 is there to get to the negative. Just notice that mistake. Sorry about that. Now the tangent. So this is sine over cosine. So this is a special angle. So that's to get exact values. We have to use the special angles. So this is like 1/2 over the square root of 3 over 2 and negative. But tangent inverse, we pull them out of tangents positive here, negative here, and negative here. So we could go this way or we could go this way, but the principal value says go this way because tangent's 0 here. If we went this way, we'd have an undefined right there. So you pick it out of these somewhere between minus pi over 2 and pi over 2. And we want the sine to be 1/2. So that could be plus 1/2 up here or minus 1/2 here. And the cosine to be the square root of 3 over 2. So it would be either there or there. But the tangent is negative, so it has to be here, which is minus pi over 6. And so that means the 1/2 was negative and the square root of 3 over 2 was positive. Okay, this one says do everything in radians. And if I look at x, this is the adjacent and this is the hypotenuse. That's a right angle. So the cosine of x radians is 17 over 37. So pulling out my calculator and going second, clear, go to mode and make sure I'm in radians. I am. So I now do cosine inverse of both sides of 17 divided by 37, and I get x to be 1.093 radians. And that's like 90 degrees, so these have to be 90 degrees, or pi over 2. So if I take pi divided by 2 and subtract that answer, I get what y has to be, which is 0.477 radians. And then z, since I have a leg and not this one, and I got the hypotenuse squared minus a leg squared is how you get the other leg squared, by taking the square root. So I have 37 squared minus 17 squared to the 0.5 power is taking the square root, and I get 32.86 is how long z has to be. On this one, now I'm doing degrees, so I'm going to go to my calculator and change my mode to degrees before I forget. And x, see, this is opposite leg and adjacent leg. That's the hypotenuse, leg and leg. So opposite over adjacent is the tangent of x in degrees is 81 divided by 100, which is 0.81. So to get x, I'm going to go tangent inverse, and I changed my mode to degrees already, of 0.81, and I get 39.01 degrees. And 90 minus that answer is y, which is 50.99 degrees. And z is going to be leg squared plus leg squared square root. So that's 100 squared plus 81 squared square root 0.5 power is 128.69. All right, these are tricky. So the sign on the circle, the sign inverse, so we have to pick it between here and here, and it's positive, so we have to be up here. And if this is 1 or 7/7, 3/7 is about there. So we're going here where the y is 3/7, and we want the cosine. So it's got to be this one right here. It's got to be a positive answer. This side is 3/7, this is 1. So square root of 1 minus 3/7 squared, 9/49. 1 is 49/49. So 49/49 minus 9/49 is 40/49. Now it seems like you could do plus or minus because sign is positive here. But the inverse is saying pick it in these two quadrants, pick it right here, And so the cosine has to be positive. Now, this can be reduced, by the way. This is 4 times 10. Square root of 4 is 2. Square root of 10 stays. And square root of 49 is 7. Okay, 7 pi over 6. It's tempted to say this just cancels the sign, but it doesn't. The sine is 7 pi over 6. 1, 2, 3, 4, 5, 6, 6, 7, 6 is right there, where the sine is 1/2 negative. Now I got to find an angle in these two quadrants, because sine inverse comes out of these two quadrants if I'm using the principal value. So I got to come out of these two quadrants for the sine inverse. Well, then I'd have to use this angle where sine is negative 1/2, and that angle is negative pi over 6. Cosine inverse. So cosine, we get it out of these two quadrants, and so if it's going to be negative, it's got to be over here, not over here. 3/4, half, quarter, half, 3/4 here. We're someplace there, so we got this angle. And we've got to find the tangent of it, where this is negative 3/4. So this squared plus this squared's got to be 1. So 1 minus negative 3/4 squared will be this side. And so that side has got to be, let's see, 3/4 squared is 9/16. Subtracted from 16/16 is 7/16. And if the cosine's negative, the sine is positive here, and we're figuring out the sine, this side. So we have to use the positive one, not the negative one. So this is the square root of 7/4. That's this side. And the sine, the tangent is the y over the x. So it's square root of 7/4 divided by the x minus 3/4. And if I multiply the numerator and the denominator by 4, the 4's cancel. And I get square root of 7/3 and negative. Okay, moving on to the back page. The exact solutions on the interval 0 to 2 pi. So I'm solving for cosine of x, so I subtract the square root of 3. So 2 cosine x equals negative square root of 3. I divide by 2. And so this is a special angle. The cosine of the angle is negative square root of 3/2. So the sine is 1/2, or negative 1/2. But the cosine is negative square root of 3. So I'm either here or here, which is 1, 2, 3, 4, 5 pi over 6 plus multiples of 2 pi, or here, which is 7 pi over 6 plus multiples of 2 pi, or negative 5 pi. So the cosine inverse, you just can do a plus or minus. But now we have to find the ones that are between 0 and 2 pi. Well, we know the 5 pi over 6 is in there. If we add 2 pi to that, we're too big. Go around again, we'd be way over 2 pi. And if we want negative 7 pi over 6, it's not in between, but if you add 2 pi to it, you get that 7 pi over 6. And there's your two answers for this one. Now this one. Divide by 2, and we've got the sine of 0.5x equals 1/2. A special angle. There's two places where the sine is 1/2. 1/2, it's here at pi over 6, and here 5 pi over 6, where it's 1/2. So we have pi over 6 plus multiples of 2 pi is all the solutions for this place, and all the solutions there are 5 pi over 6 plus multiples of 2 pi. And that's what the angle has to be, that 1/2 x. Now to get the half off of here, we have to multiply everything by 2. So x is going to be 10 pi over 6, which reduces to 5 pi over 3, plus multiples of 4 pi, if we're multiplying by 2. So these become these. And of these, the ones that are between 0 and 2 pi are just 5 pi over 3. And adding 4 pi would be too big, so there's one answer. Looking at this, multiplying by 2, I get x equals, and this will become 2 pi over 6, or pi over 3, plus multiplying that by 2, we get multiples of 4 pi. So we get pi over 3. And if we add 4 pi or subtract 4 pi from that, we're not between there. So there's the two answers to this one. Now it says find all solutions. So the secant, 3 times the secant equals 5. So if you divide by 3, you get secant of an angle is 5/3. Secant is the reciprocal of cosine. So the cosine of x is 3/5. And the cosine is 3/5 right about here, positive 3/5. So we get angles that are up there and down here. The calculator will give me angles up here. It'll give me this one. So let's find out what that is. And we're doing this in radians. So make sure I'm in radians. So I want to do cosine inverse of 3 divided by 5. And it says the angle here is 0.9273 radians. And I can do multiples of 2 pi from there, plus multiples of 2 pi. And this angle is the same as this one, it's just down here, so it's negative of this. So it's plus or minus this plus multiples of 2 pi. Okay, now this one. Some people saw this was a quadratic, and they tried to factor. This is something squared plus 3 times the something equals 2. But when you're solving quadratics, some of you forgot that you need to make it equal to 0. So if I use a different variable for this, I'll just say this is like 2a squared plus 3a minus 2 equals 0. To factor it, it's 2a and a, and it's got to be something to multiply. It's be negative 2, so 1 and 2, and we have to get plus 3. So if I put plus 2 here, I get 4a, and I put 1 here, negative 1, I get minus 1a. 4a minus 1a is 3a, this makes minus 2, and this makes 2a squared. So I have 2 cosine x, because a was my a, cosine x was my a, so this is minus 1. That's one factor, and the other factor is cosine x plus 2. If I have two things to multiply to be 0, I can either set this one equal to 0 or that one equal to 0. If I set this one equal to 0 and subtract 2, so if it's equal to 0, subtract 2, I get cosine x equals minus 2. Cosine never reaches minus 2, so there's no solutions here. Let's look at this one. If I set that equal to 0 and add 1 and divide by 2, I get cosine x equals 1/2. And there's a bunch of solutions for cosine equal to 1/2. Again, on the unit circle, if cosine is 1/2, we're up there or down there. So we got pi over 3 plus multiples of 2 pi. And down here, it's also the minus pi over 3. So we got that way, or you could say pi over 3 plus multiples of 2 pi and 11 pi, no. Let's see, 5 pi over 3 plus multiples of 2 pi. Another way to say it. And finally, the last one. There's a weight hung on a spring. So there's a spring and a weight. And if it's at rest, this is 3 feet from the floor. And it is pulled down to a foot from the floor. So this is pulled down to here, which is going to stretch the spring to where it's a foot. And if you let go, it's going to go up 2 feet above this and then back down to here. And as time goes on, it's going to go start from here. It's going to go up and down and up and down and so on. So here's kind of the center line at that 3 feet above the floor. And it looks like if I pull it down by 2 feet, it's going to go above by 2 feet. It's going to decrease as time goes, but to start off with, it's going to look like this. And at time 0, it's at the bottom. So this looks like it could be written as a sine curve, but then you have to shift it sideways. It's easier just to say an upside down cosine curve with an amplitude of 2. The height would be this. And the period, what was the period? Every half second. So we do 2 pi divided by 1/2, which turns out to be 4 pi. So we put 4 pi times the time. Don't have to shift it because I started it at the bottom. But the whole graph is up 3. So there's equation for the position. And I asked when it was 4 feet. So that would be somewhere in here. I want to know how much time has passed to get to there. So now I'm going to pull out my calculator. And I'm going to type negative. Oh, I've already got it typed in there. And I want to know when it's 4 high, so I put 4 in there. And if I go zoom 6, doesn't look very good. We need to spread this out. We need to go window, we need to go from not 10 seconds, we need to go from 0 to maybe 1 second, because it makes a whole cycle in 2 seconds. And we only need to know from 0 to maybe 5 high. Now let's graph it. So the first place that it hits is right there. Gets up to 4, and then it comes down to 4. So I need to find that place. So that's going to be second, calculate the intersection of the blue graph, yes, enter, red graph, yes, enter, and I'm going to move close to where I want to know. I want to know this intersection, not that one, not that one, not that one, that one. So I'm going to press enter, and it says at time equal to 1.1666 seconds. Now we could also write 4 here, subtract 3, get 1, divided by that, we get negative 1/2 is the cosine of 4 pi t. And so when the cosine's a half, negative 1/2, negative 1/2 would be right there. No, cosine. Negative 1/2 would be negative, well, let's just do there, positive pi over 3. Nope, that's not negative. Negative 1/2 is over here. So if I start from 0, time going on, that would be 2 pi over 3 is the angle. And so we got 4 pi t, so we got to take 2 pi over 3, 2 pi divided by 3, and divide that by 4 pi, and we get the same time.